Okay, so for Module 4, the first thing that we're going to tackle is just a basic drip rate problem. Given information about an amount of fluid you want to administer over a period of time, how do you determine what is known as an observable drip rate? So the key here is the word observable. This has to be something that you could actually see and follow if you were standing at the IV kit with your watch. So an observable drip rate, as an example, might be something like 15 drops in 20 seconds. So if you can sort of imagine yourself standing there looking at the drip rate chamber with drops coming down out of the drip rate chamber, and you held your watch for a 20-second period of time, would you be able to count 15 drops in the 20 seconds to verify that the IV was progressing at the correct rate? An example of a drip rate that is not observable, so we'll sort of say bad example, would be something like 6.23 drops in 10 seconds. So clearly, you cannot observe 23/100ths of a drop. We'll do a little sad face. So you want to come up with a drip rate which is, as we said before, observable. And so when we do these drip rate calculations, we are going to end up with calculations that are not initially observable, but we're going to have to modify them in order to come up with an answer. So as an example, we might get something like 0.333333 drops per 1 second, which would be the same as 1/3 of a drop per second. And we might be able to augment that. So for example, if I multiply this by 30, what I'll get is 10 drops in 30 seconds. So we're going to take these unit drip rates, the number of drops per second, and change them into observable drip rates, some number of drops in a fixed unit of time that is easy to observe. So that's the goal here when working with drip rates. So let's move on to an actual problem. So suppose we are given the following. You want to infuse 1,000 milliliters over 5 hours, and you're working with an IV calibration kit. That is set at 15 drops per milliliter. So as you stand there and watch the drops go through the IV chamber, every time 15 drops goes by, that's equivalent to 1 milliliter of fluid. And what you want to do is determine an observable drip rate. And again, it's going to be some number of drops with respect to some unit of time where the number of drops is observable. So the standard way of doing this is to take the number of milliliters over the number of hours, start with 1,000 milliliters over the 5-hour period, and reduce this down to drops per second, and then modify that to get some number of observable drops in a fixed unit of time. So the easiest way that I know to do this is to start by getting out of hours and into seconds. So 1 hour is 3,600 seconds. So that causes us to remove the hours. Now we're in milliliters per second, but we want to be in drops per second. Right? So for the drops per unit of time, we're going to start with just 1 second. So the last thing we're going to do is multiply by the 15 drops per 1 milliliter IV calibration rate. So now all the units of measurement have gone except for drops over seconds. And if we do the calculations here, So the 1,000 times 15, and that's drops over the 5 times 3,600, and that's seconds. This comes out to, when you do the multiplication and division, 0.83 drops per second. Now obviously, this is not observable. If you were to convert this to a fraction, this comes actually out to be the fraction 5/6. So it's really 5 drops for every 6 seconds. Now that is a perfectly observable amount of time, but usually I like to go a little longer. So 30 seconds, or 45 seconds, or 60 seconds, and so forth. So a slightly longer interval of time will give you more of an accurate IV fluid administration. So 0.83 drops per second. If you multiply that by 30, comes out to give you 25 drops in 30 seconds. So the 0.83 times 30 gives you 25. So this part gives you the 25, but that's 25 drops over a period of 30 seconds. This we can work with. Right? You can see yourself standing there, conducting a 30-second interval, and seeing if 25 whole drops pass by during that interval. So that would be a perfectly appropriate observable drip rate. And again, you're just going to have to finesse it a little bit. Once you get the number of drops per second here, you're going to have to multiply by 30 or maybe multiply by 40 to see what's going to work. But for this particular problem, a drip rate of 25 drops over 30 seconds will work.